Hi everyone, and welcome to EasyEDA. In our previous lesson, we finished designing the web-based control interface. So in this session, we're officially jumping into the core part, writing the motion control code for our quadruple robot. This lesson is going to be divided into three main parts. Part 1 is biomimicry analysis, Part 2 is code development, and in Part 3, we'll do a quick wrap-up. Let's start with a bit of biomimicry. On the left here, we've got a frame-by-frame breakdown of a dog walking. And on the right, we have an animated GIF that shows the dog walking in real time, which gives us a clearer, more intuitive understanding of how the dog moves forward. You'll notice that when the dog walks forward, it moves its front left and rear right legs forward together, while the front right and rear left leg pull backward. This is a diagonal gait pattern. It's an alternating cross-limb movement. So, when we write our servo control mode, we need to maintain this diagonal synchronization. Otherwise, our robot won't be able to walk forward properly. Alright, let's dive into this code. Go ahead and open up VS Code. If you've been following along with the previous lessons, by now your web control interface should already be up and running. Now it's time to continue by writing the actual motion control functions. As we just discussed, when the robot moves forward, it lifts its front leg and rear right leg. In our code, the front left leg is controlled by servo 3, the rear right leg is controlled by servo 2. Now, why are the numbers this way? Because earlier, we already defined all 4 servos that map each one to a specific PMW pin. In the setup initialization function, we also assign those pins. For example, servo 1 is attached to GPIO 14, which controls the front right leg. Let's quickly review how we control servo angles. Signal width of 500 microseconds means 0 degrees. 2500 microseconds means 180 degrees. These values can vary depending on the specific servo modules you are using, so I recommend checking the datasheet for your servo or just ask your supplier. When we start things up, we initialize all servos to 90 degrees, which is a vertical neutral position that makes it easier to move in any directions from there. Now here's a key question. Why do we move servo 3 to 40 degrees? It's because we are making the leg swing forward to the neutral 90-degree position. Based on our testing, 40 degrees gives the most stable and natural looking forward motion. But feel free to try 30 degree or 35 degree and see what works best for your robot. As for servo 2, we move it to 140 degrees. Why not 40 as well? Because the servo is mounted in the opposite direction, so motion needs to be mirrored. That's how we pick the moment symmetrical and allow the robot to actually walk forward. Next in code, we move servo 3 to 40 degrees, servo 2 to 140 degrees. Then we insert a 100 millisecond delay to give the servos time to move. After that, we control servo 1 and servo 4 to swing backward, again using a mirror angle. Add another 100 millisecond delay here as well. Finally, we reset all servos back to 90 degrees. We can do this in 2 steps. First, return servo 2 and servo 3 to 90 degrees. Then return servo 1 and servo 4. Insert a delay after each step to ensure smooth transitions. Our full forward steps look like this. Servo 3 to the front left, and servo 2 to the rear right swing forward. Servo 1 front right, and servo 4 rear left swing backward. Then reverse, servo 1 and servo 4 forward, and servo 2 and servo 3 backward. Finally, reset all servos to 90 degrees. We add a 100 millisecond delay after each movement to keep everything smooth and synchronized. Now, backward movement is super straightforward. It's just the opposite of the forward movement. Where we previously used 40 degrees, we now use 140 degrees. And where we use 140 degrees, we now use 40 degrees. Everything else remains the same. Turning is a little trickier. It's not just about swinging 2 legs forward at once. It's all about creating an angle difference to shift the robot balance and generate a turning force. For a left turn, we start by moving servo 1 and servo 4 from 90 degrees to 100 degrees. That gives us a small 10-degree difference. Next, we move the diagonally opposite legs, servo 2 and servo 3 to 60 degrees, creating a bigger difference on that side. So we've got one leg pair with big angle shift, one leg pair with a small shift. This imbalance helps the robot pivot to the left. Then we deepen the angle difference. Servo 1 and Servo 4 to 140 degrees. Servo 2 and Servo 3 go to 40 degrees. And finally, we return everything back to 90 degrees. Right turn works exactly the same way, just reverse the angle directions. Let's break these down. Sit down equals to move Servo 2 and Servo 4 forward to 140 degrees. Hold for 1 second, then reset. Lie down. Move Servo 1 and Servo 4 front legs to 180 degrees and Servo 2 and Servo 3 to 0 degrees. Hold for 3 seconds, then return to 90 degrees. Top left hand, move Servo 3 from 0 degrees up to 30 degrees, then back to 0 degrees, repeat 3 times. Same for Servo 1, move 180 degrees down to 150 degrees, then back to 180 degrees, also repeat 3 times. This one is handy for storage and transport. We just fold all the legs inward. Servo 1 and Servo 4 is 0 degrees, Servo 2 and Servo 3 is 180 degrees. Now the robot's in a compact, low profile position. At this point, we've finished writing all the motion functions. You can now test any function by calling it inside your loop function. Quick review of the uploaded steps. Upload the jumper between IO0 and GND. Hook up your USB to serial module, TX to RX, RX to TX. If you're using a battery for power, don't connect the 3.3 volt pin. Open your flashing tool and click upload. When flashing is done, remove the jumper and restart the board. Watch your robot to see if action runs as expected. Now you can try different motions like left turn, sit, or wave and check if they're performed correctly. So here's what we accomplished in this lesson. We analyzed how a dog walks using biomimicry principles. We explained how servo angles work, 0 degrees, 90 degrees, 180 degrees. We wrote a full set of motion functions, forward, backward, left turn, right turn, sit, lie down, wave, and pack mode. And we actually tested it by uploading the code to the robot. You can now try writing your own dance function or create custom motion combinations to take your project further. That's it for today's session. Thank you for watching, and I'll see you in the next lesson.